Helium is the primary DART ionization gas used across all applications. It's largely used as the ionization gas in DART because the excited helium metastables have the highest ionization energy of any of the other metastable species, therefore giving it the greatest capability to ionize the largest variety of compounds. However, in the face of the current helium shortage, it's important to explore more sustainable alternatives as well. Nitrogen is much more readily available than helium. The ionization efficiency of excited nitrogen is high enough that almost all but the very smallest organic compounds can be easily ionized with nitrogen gas as well. In fact, some compounds actually ionize better by DART using nitrogen as the ionizing gas versus helium. You can see that here in the DART analysis of the explosive RDX. The bottom spectra shows the M+H parent ion and was produced with helium as the ionization gas. However, when comparing that to the top spectra, which was produced with nitrogen, the signal of the RDX parent ion improves and shows a cleaner spectra with lower fragment ion. Nitrogen gas ionization with DART often shows less in-source fragmentation than helium DART, due to the higher internal energy of the helium metastables. This was described by Dr. Liguo Son in a recent publication in the Journal of American Society for Mass Spectrometry. Dr. Son directly compares the ionization of diethyl phthalate and progesterone by both helium gas and nitrogen gas. For both compounds, nitrogen ionization shows much less in-source fragmentation. When looking for cleaner spectra that is easier to read, this is of course preferable. Armed with this knowledge of nitrogen gas's advantages as an alternative ionization gas for DART analysis, we explored more sustainable and cost-effective sources of nitrogen for DART. The NG3000A nitrogen generator from Peak Scientific is a commercial generator that can produce nitrogen at an ultra-high purity, which at 99.9995% is similar to the grade 4.8 nitrogen cylinder tanks generally used. Nitrogen generators we have assessed in the past have not worked well with the DART, which we attributed to the lower grade purity of the nitrogen. Our recent performance qualification tests of the NG3000A, however, showed that the generator produces statistically the same signal response and sensitivity as the nitrogen tanks do with DART-MS analysis. You can see this here with our parallel analysis and positive polarity of cocaine, with both different nitrogen sources, as well as here with the parallel analysis and negative polarity of the explosive BTN. The similar data produced by both nitrogen sources indicate that the generator is as efficient as the tanks, eliminating the less sustainable and more expensive need for cylinders.